Let's start with few problems related to theorem that we discuss. We have this figure, I think we have drawn from the question. Let's start with the question. In triangle PQR, if S is any point on the side QR, we have triangle PQR and S is the point you can take anywhere on the QR, anywhere. Show that PQ plus QR plus PR greater than 2PS. This is what we need to prove. So we have this point anywhere on the point S, anywhere on the QR, not midpoint or like something like that. So no conditions. Anywhere you can take it. S you can take here as well, right? Though you will get the same result. Okay. So what we need to prove, first of all, let's mention that we need to prove that PQ plus QR plus last is PR greater than twice PS. This is what we need to prove it. How shall we approach it? Okay, so how to understand this one? First of all, focus on 2PS. How to think it in the reverse way. Now 2PS can be written like this. PS plus PS we know very well. We are good at algebra. So what does it mean? So you need to get two conditions for the PS, right? One condition for this PS, then another condition for the PS, and you add them. This is what we are supposed to do. This is what is the interpretation of this one, right? So PS is over here, right? Now if you see properly, PS side belongs to two triangles at a time, right? This is the one triangle, right? And this is the another triangle PS belongs to, right? Now see, this is about the inequality. So what is the theorem that we learn about the triangles and inequality related to side, right? Sum of two sides is greater than the third one. So that's what we are going to do. First of all, for this triangle PQS, afterwards PS and R. So first let's start for triangle PQS. Here triangle PQS, right? Let's write sum of two sides is greater than third side, right? So now observe one thing. Don't take the side with PS over in the sum, right? Take PS separately. That is what we want. So if we take sum of two sides, that is PQ plus QS, let's write PQ plus QS is greater than PS, right? This is the first condition we get it. Now let's get the another one, that is for triangle PSR. For triangle PSR, we can write again, keep the PS on the right hand side. So we have PR, let's write here PR plus SR is greater than what? PS, right? So we have this two result. This is the first result and this is the second result. Now you observe in the result that we need to prove. What are we supposed to do of these two PS values, right? Indirectly, condition not the values, condition for the PS, we are supposed to add them. So let's add. First of all, let's start with this one. So PQ plus QS, right? And here PR plus SR greater than here PS and one more PS here, right? So very simple it is. We have PQ, now QS and SR. What will you get if you add QS plus SR? See, this is the like two parts of a side QR. Very simple it is, right? This is QS and this is SR. So if you add them, you are going to get what? The longer side, that is QR, right? So let's write PQ as it is plus then PR, then finally QR greater than PS and PS. How many times? 2 times PS, right? So this is what we proved it, right? That's we wanted to prove. The order is little bit different, doesn't matter. Addition is commutative. Either you write QR at the last or in the middle. It means same. If you want to still write it, you can go ahead. So PQ plus QR plus PR is greater than 2PS, right? Very simple it is. So let's Recall what we did over here. So we have two triangles, and for both of them we follow the triangle inequality theorem. That is, sum of two sides is greater than the third side. We applied for this triangle PQS and PSR. Now while you apply it, you need to keep in mind PS should be single, not in the sum, because see, that's what we wanted to get, PS separately, right? So keep PS that side and rest of the two sides on your left hand side. Same we will be doing for the next triangle. Then add them up. How do we come to know that we are supposed to add? See, here it is positive, PS plus PS. So because of that, we have added these two results, and finally we get what we need to prove. Let's discuss one more question related to proving the results of inequalities. In the given figure, angle B is greater than angle A and angle C is greater than angle D. Show that AD is greater than BC. Okay, so let's start. We have first of all given conditions. So let's start with the given condition. What are the given condition? Angle B is greater than angle A, and another condition we have C is greater than D. So angle C greater than angle D, right? This is the another condition. And what we need to prove? We need to prove that here AD is greater than B, AD is greater than BC. So we need to prove that AD, length of AD is greater than length of BC. This is what we need to prove over here. So how shall we prove it? We have two triangles, but rather than the triangles, focus on these two conditions, right? These two conditions, if you use it, you will get the answer. If you don't use it, you will get confused and won't be able to get it. So let's start with these two conditions. The first condition is angle B is greater than angle A. Now, we know very well, let's write here, angle B is greater than angle A, right? Now we know very well that side opposite to larger angle is what? Longer. So let's mention that side opposite to larger angle is longer, right? We know very well. Now here angle B is greater. So what is the opposite side of angle B? That is, here only talk about this triangle AOB, that is AO. So we can write AO greater than opposite to angle A, that is BO. So done here. Let's write the same condition for the second one, that is angle C. Angle C is greater than angle D. So opposite to angle C is here and opposite side is OD, or we can write DO, greater than opposite to angle D. Angle D is here and opposite is what? CO. So we can write CO over here. Then now we have two results. Let's say this is result 1 and this is result 2. Now let's add them up. So AO here plus DO. Remember, both are greater, right? Don't use the different sign over here. If you use greater than, then keep using the greater than. Don't use the less than, you will get the incorrect answer. AO and DO over one side, then greater than, then BO plus CO. BO plus CO. Now see over here, AO is this and DO is this. Now if we join these two sides, what are we going to get? Yes, we are going to get AD. So AD over here, then greater than, then BO plus CO. This is the BO and this is CO. So if you connect them, you are going to get what? BC. So you can see that we are done with the sum. Very simple to do, right? AD is greater than BC. Just follow the two conditions and write the side opposite to the given angle. That's what we have done in the both of the case. And finally, add them. How do I get the idea about the adding them? Right, little bit like confusion, it happens. AO and DO. See, we get the AO and we get the DO. If you add them, we are going to get AD. So this is the reason why we added them, right? So follow the two conditions then write the greater sides based on the angle, then add these two conditions, and this is how we prove that AD is greater than BC.